We're at 9.1, classifying, so 372. Classifying and evaluating polynomials. Polynomials, whoops. Kind of ran over there. So 9.1, classifying and evaluating polynomials. All right, a polynomial, what is it? It's an expression written as sum means adding of terms consisting of constants variables with non-negative, whoops, there should be a little dash there, non-negative exponents, or product. Product means multiplication. Of a constant and one or more variable. And I know you guys heard blah, 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 blah. So we're going to talk about it. So polynomial. It's an expression, not an equation or anything, just an expression, like what I call a math sentence, written as a sum of terms. And when it says sum, we're talking like adding and subtracting. This is the way the math world writes it, but it's really like a math sentence that is separated by groups or terms by plus or minus sign, consisting of constants. What are constants, Taylor?
Numbers.
Yeah, numbers. Constants are numbers. Why they can't say that, I have no idea. It would make more sense. So it's basically groups of numbers and variables separated by plus signs and minus signs. And the variables cannot, they're non-negative exponents. What does non-negative exponents mean? Yeah, exactly. Why they can't say variables with positive exponents, I'll never know. Why can't they say that? But that's what I'm saying. In the math world, this is the definition or the example. So there are teachers that I've been friends with for over 20 years that believe, and there's professors, I'm going to warn you, that really believe, well, all the information's right there in the first couple of pages of the book. They can teach themselves. I'll be there to answer questions. Really? So you're telling me you can decipher what this means, you know? And so I'm like, no, constants means numbers, variables are your letters, non-negative exponents, positive exponents, or product of a constant and one or more variable. And I'm going to give you an example of that. Yes, Taylor?
What you were just saying about professors doing that, is that somewhat correlating to the picture that you sent them on?
I can't remember the picture I sent your mom.
It said,
yes, yes, exactly. They're teaching the curriculum and not the student. Allie has I'm just preparing you. There's some professors out there So again, like what we were having a discussion before this, Allie can't use that as an excuse with her professors. She's in college. She can't say, well, they're not teaching me. She can't go to the principal, and your parents can go to the principal and say, well, the professor's not teaching. What's that noise? Anyway, so what she has to do is now say, oh, gee, I have to teach myself in this class. So she has to find a way to teach herself. Khan Academy, I don't want her asking me, but she can find help. Otherwise, she's paired up with friends and stuff like that. So that's kind of my motherly lecture to y'all earlier. Find ways to be successful. Okay. So anyway, let's start going into that. I'm going to give you an example of what this all is. There are 3 types of polynomials. Basically, these are the rules. This is the biggest one. You can't have a negative exponent. That's pretty important. There are 3 types of polynomials. There's a monomial. And a monomial means that there's one term. And I'm going to give you an example. 8ab squared c. Write that down, and I want you to look at it. That's a polynomial. Right here. Or a product of a constant. Oh, look. There's an 8. That's a constant. And one or more variable. Look at the one or more variable. I have an a, b, and c. And we have a non-negative exponent. Positive. In fact, if you want to write positive right here, be my guest. So this is a polynomial, but it's called a monomial. It's a monomial polynomial because there's one term. This whole thing right here together is one term. So that group is called a term. Now I'm going to show you binomial. And then you'll be like, oh, I get it. Binomial. Bi meaning 2. So it's 2 terms. And it's going to look like this. And this is just an example. 5x squared plus y squared. It's a binomial polynomial.
Because there's technically a 1 in front of the y.
Well, I mean, yeah, basically. So if you look back up here, it's an expression. Here, this is an expression written as a sum. Here's my plus sign of terms. Well, here's a term. And here's a term. 2 terms. 2 terms. So, an expression, here it is, as a sum, here's my plus sign, of terms consisting of constants, oh, well, there's a 5, and variables, these are my variables, with positive exponents, okay, the exponents are positive, and there you go. So that's a polynomial. It's a binomial polynomial. There's 2 terms. Yes, sir?
So there can't be a minus sign?
Nope. So those of you that hate negative exponents, you'll love this. Because if you see a negative exponent,
Something's not right.
something's not right. And then the last one, trinomial. Guess how many terms there are?
3.
700.
Yeah.
3 terms.
So there's no quadrinomial.
No. That actually, I think, is called other polynomial. They have monomial, binomial, trinomial, and I think and then after that it's just other polynomial or something like that. I'll have to refresh my memory. So I'll give you an example of that. 2a squared b to the 5th power plus 8c to the 4th power minus 2a to the 5th power. And instead of circling them, I'm going to just say, here's one term, 2 terms, 3 terms. So I have 3 terms. Basically, 3 groups. And y'all did something similar, on that 6 weeks exam where you had the groups. You know what I'm saying? So you've already kind of seen this. So these are the 3 types of polynomials. So before I move on, are there any questions? All right. So let's go over some rules. The main one that I've already actually discussed up there. And what y'all are asking. So let's say I have x cubed y to the negative 2. Remember up here, has to have a non-negative or positive exponent. So because of that, it is not a polynomial. It is not a polynomial. And I'm going to take it one step further. If you have this, that is not a polynomial, and I'll show you why. Because there's an exponent in the denominator. Because if I were to move this up, wouldn't that make it negative? Absolutely. If I were to move that y squared up on top, it would make it y to the negative 2. That's how we handle negative exponents. And since you can't have negative exponents, you can't have an exponent in the denominator. So, 3 stars can't have negative exponent or exponent in denominator of fraction. So make sure you have that written down. Lots and lots of stars. Can't have a negative exponent, and you can't have an exponent in the denominator of a fraction. So some of you that don't like negative exponents and don't like dealing with exponents in the denominator, this is your chapter. You can say, okay, this looks like something that I can handle. Taylor.
When we start examples, can we use the bathroom?
Lord. Yes, you can when we start examples. Does everyone have it? All right. We're going to learn now about degree of term. Degree of term. Now, the only part that's really kind of confusing is you've got to remember all this stuff because they're going to ask you what's the degree of the term. List the degree of the term, and you're going to be like, I don't remember what they're asking. as soon as you read it, you're going, oh yeah, I remember how to do this. But it's remembering all of this stuff that's the problem. Again, practicing over and over again is going to get you there. The degree of the term is the sum, remember that's adding, of the exponents of its variables So the degree of the term is the sum of the exponents of its variables. And I'm just noticing there should be a period there. In other words, you are adding the exponents of the letters. There. So you're adding the exponents of the letters. Adding the exponents of the letters. Now I'll give you an example. They're going to try to trick you. Like legit, they're going to try to trick you. So be careful. So, for example, 5x cubed y squared z to the fourth power. If I were to say, what is the degree of the term? Remember, this whole thing is a term. There's no plus or minus sign and another group of letters and numbers, so this is one term. So the degree of this term, anyone want to guess? Aiden? 9. And some of you are like, what? Adding the exponents of the letters. So 3 plus 2 plus 4. 3 plus 2 plus 4 equals 9. So you're adding the exponents of just the letters. There's your answer.
That's pretty cool.
Right? That's not bad. That's using very little brain cells. Okay, the problem is remembering what they're asking for. When they say, what's the degree of the term? Because there's several I'm about to go over, and you got to remember, what is it again that they're asking for? And like, they may trick you and put like a 2, an exponent with this 5, and you got to remember, oh yeah, I'm not supposed to add that. So it's gonna be the tricks and everything that may get you, but really the definition is just adding the exponents. How about if it's 4x squared y? Taylor? 3. Because we pretend that there's a 1 right here, and we're adding 2 plus 1 equals 3. Are there any questions? Cecilia? Huh? In your math classes in high school?
Do we use it outside?
Some people will. It depends on your career.
What type of jobs?
Yeah, what type of jobs? Huh? Oh my gosh. Anything that deals with like architecture, engineering, physics, stuff like that. Any of your science and math careers, you may be dealing with this stuff.
When did they start putting math into science? What grade?
When do they start? Probably next year.
They already started the bed this year.
Yeah, I'm pretty sure you'll start getting math and science starting next year, no matter where you go. All right. Any other relevant questions to what I just showed y'all? All right, let's move on. Degree of a constant. What's a constant again? Cecilia, what's a constant? Huh? What's a variable? Cecilia, do you know what?
Number.
Huh? Yeah, this is a number.
Why don't they just say number?
I don't know. That's why I'm putting that on there because, you know, some teachers would just say, "What do you mean you don't know that that's a number?" You know, I mean, that's why I'm putting that on there because it's dumb. All right. So anytime they ask or you need to know what the degree of a constant is, the answer is always going to be 0.
Oh, nice.
For example, if they say, what's the degree of 567?
That's the answer.
That's all, yeah. As I stand outside the math class. The answer is 0.
I like this.
What's the degree of this constant?
0.
0.
I have a question. If it has an exponent, would it still be 0?
I don't think. Yeah. Because, for example, that's a good one. I'm sitting here thinking. What's 5 squared?
25.
What's the constant of 25? I mean, the degree of that. It'd be 0. Good question.
What's that with me?
Very good question. I like that.
What
Made
if
me
it's-
think.
What if it's a fraction?
No, they're not going to do that.
What if they do?
Okay, let's say they did. That's still a constant, right? It's still a number with no variable, correct? So, then I'm assuming it's also going to be 0. Because it's a constant. We're just dividing it by constants and variables. Constants are your numbers, variables are your letters. So regular old numbers are going to have a degree of 0. Degree of term, for these, you're just adding the exponents of the variables. Don't even worry about those numbers. They're just there to throw you off. Okay, here's another one. Degree of a polynomial. Okay, so we talked about what a polynomial is. This is a polynomial. It's a whole group. Here's a polynomial. It's a group. But we also talked about a polynomial can have 2 groups, or a polynomial can have 3 groups, right? These are all polynomials. So here, up here, we did degree of the term. So just one group, we found the degree. For a degree of polynomial, it's going to be for that whole math sentence, okay? And here's the rule for finding the degree of a polynomial. Again, degree of term, you just add the exponents of the letters. Degree of a polynomial, you're going to get the highest degree of any term in the polynomial.
So it's not adding all of the terms is
It's the highest one.
degree of terms is the highest one.
Exactly. You're going to find the degree of all the terms, and then the degree of the polynomial is the highest. For example, 3x cubed y plus 2x minus 4xy squared. Okay, now write this down and let's talk about it. If you're worried about homework tonight, I'm not giving y'all any homework tonight. I want to just kind of go, we're going to do notes and stuff like that. see how far we get, and then probably tomorrow do the examples and stuff like that. Okay, so I want to make sure that you have a good understanding of this coming off of a 6 weeks exam.
So I can't get to bed.
Taylor, it's your choice if you want to go right now, if you want to go later, but I'm not reteaching this. And I'm recording this whole conversation about you in your bathroom visit. So you decide what you want to do. I haven't started teaching it. Why are their hands up? Whit?
Well, I just have a question. Like on the top part, at the degree of term, are the examples, are they polynomials?
Remember, like, see, this is one group. That is a monomial.
Then why did we add them? If
Because they asked for the degree of just the term. They asked just for the degree of the term. This is one term. Okay? Does that make sense? Aiden?
The one that we're doing, I thought there could be a subtraction.
Yes, there can be. Like, look right here. There's a minus and a plus.
It's not the exponent.
Yeah, it's not the exponent.
Hey, can I ask you a question earlier? I think
Okay. Yeah, no negative exponent. No negative exponent. Okay. Cecilia.
For the degree of term, what do you do when you have a negative exponent?
Sweetheart, we're here. It's not a polynomial.
Okay.
You do nothing with it. You don't,
Degree
they,
of term?
huh?
For degree of term?
For anything.
Okay.
You cannot have a negative exponent, period. So you won't be dealing with that. They would never ask you that because you cannot have a negative. It's not even a polynomial. Okay, so the degree of a polynomial. Let me ask you this. Is this a polynomial?
Yeah.
oh no, yeah.
Yes, it is. Because we have numbers and letters being multiplied here. We have positive exponents. And it's separated by plus and minus sign. So what kind of polynomial is this, Emily? The 3 one. What's it called? Trinomial. Think of a tricycle, a tripod. No, tri, 3. Okay, so we have 3 groups. Good job. Michaela, what are each of these groups called?
Constant and a variable.
Okay, constant and variable, but each group is called, Cecilia? Well, this whole thing is a polynomial, and yes, we can do that. Aiden?
a term.
Term. See, there are 3 terms. Each group is called a term. And the reason I'm spending a lot of time on this is because there's going to be questions and lingo that they're going to ask you, how many terms are there? And you're going to be like, wait, what's a term? So I need y'all to get used to using some of the vocabulary. So we have 3 terms here. So if they were to ask what's the degree of the whole polynomial, you find the highest degree of any term. So we go back up here and we find the degree of each term. What is the degree of that term? Raise your hand. Gabby. 4. Because it's 3 plus 1 is 4. Does everyone see that? Michael, what's the degree of this term? 1. Olivia, what's the degree of that term? 3. Because we pretend there's a 1 with that x, we add the 1 and the 2 and we get 3. Any questions so far? So the degree of this polynomial, we have to find the highest degree of the term. So Emily, which term had the highest degree? The first one. That one is the highest. So therefore, the answer is 4. So the degree of this polynomial is 4. Write it down, make sure you have it all written down, and then ask questions. So all you're doing is you're writing down underneath, the degree of each term, and then we decide which is the highest, and it's 4. Now, Cecilia, I have a question for you. Did we even have to worry about the big 3, the big 2, or that 4? Nope. Don't even have to worry about it. Didn't have to worry about that plus, that minus, or anything else when they ask what's the degree of that polynomial. They just want to know what the degree is for each term, and you choose the highest, and that's the degree of the polynomial. Any questions? I think the problem is this stuff is so basic that you're expecting something worse, and so it's hard to relax on this stuff. I think that's, the day after a major exam happens. Another rule. You need to write polynomials in descending order. You need to write them in descending order. Now I'm going to give you examples on that. Especially since I'm well aware you guys are going off to different schools and everything. Morgan from last year came up to school yesterday and talked with me a lot and told me how it's going at her school. And, every teacher's different. I'm always telling y'all that, so you got to be prepared for anything. And her teacher would absolutely freak out over some of this stuff. So if y'all think sometimes I'm being picky, I'm preparing you. Okay, so the example is, what if they gave you this, or you did a bunch of work and this is what you got? Now, me, and in this class I've told y'all, I'm not going to count off if y'all have it out of order. Well, we need to start getting in practice for it. So you have to rewrite that in descending order. So by looking at that, Michael, what would come first? Cubed, yeah. So 6x cubed comes first. Let's see. Taylor, what would come next?
4x2.
4x squared. What would come next, Gabby? X. And Aiden, what would come next? 3. Your constants are usually always last. When they're by themselves, you need to just go ahead and put them at the end.
So it's big as large to small.
Yeah, descending order, that's right. And you're focusing on your letters. Now, the big question, what if you have something like this? 2xy. What if you have multiple letters? Minus 7x squared y plus 6x to the 4th. Aiden?
Would you combine the terms?
Combine the terms?
Terms exponents,
Like,
from x and y to x and y this way, and then would you do it over that way?
I think you know what you're saying, but I'm having trouble following.
He's asking if you first find the combined exponents for each of the
Like terms?
combine the variables for each term and then put it in order of the terms. So basically you do the degree of a polynomial and so till you find all of them and then you do it in order of that is what he's asking.
I'm not quite sure what y'all know. Let me just show you what to do. I'm just going to show you. You go A, B, C order. Yeah, A, B, C order. X, X, and X comes before Y, correct?
Yeah.
All right, which one of those X's is highest?
7x squared.
Huh?
6x.
Oh, whoops.
X to the fourth is highest. What's next?
7x2.
7x2, Y, don't forget the Y, and then 2xy. That's how you solve it.
What do you got in the same answer?
Oh,
Okay,
for this problem,
Okay,
just for this one. Very good.
see, this is what I'm talking about. People explain things. Imagine having them as your teachers. I'm over here going,
Can I quickly?
No, I'm not saying you're wrong. I'm saying that your explanation may give some of us in here headaches. Okay, so basically, guys, it's ABC order. If they all have an X, which goes before Y, so you put all those in order, greatest to least. Does that make sense? And then if you had a term that was just a Y, it would go there on the end. Make sense? Okay. I'm not saying that y'all's explanation is wrong.
It was.
It was wrong. Yeah.
Oh, okay.
It just happened to work for this one.
Oh, okay. Oh my
I'll
gosh.
tell you what we were saying later.
Oh, I look forward to it. Okay, go ahead and open your books to page 372.
Yay, man.
Do you really need to go a second time?
That was a joke.
Oh, it's like, my word, I need a porta potty in the back of the room. All right, and I really don't want that either.
It's just
Okay.
carved to the side of the wall.
Okay. Oh, I love this class. All right, number 1. Everyone open their books to 372. Okay, so number 1 says, state the degree of each term. So we have 4x to the 5th power, y to the 2nd power. Okay, so this is why your notes for this really need to be neat, because when they ask you this, I guarantee tomorrow, because I'm not going to assign homework, tomorrow if y'all start on this, a whole day has gone by, and you're going to be staring at that like, I forgot what they're asking me to do. Degree of term, what does that mean? What's a term? That's why you need good notes so you can refresh your memory. Okay, so Emily, what is the degree of this term? If you need to, look back at your notes. Yeah, she's right. Say it out loud, loud and proud.
7.
Very good. 7.
Oh my gosh.
See, I love this class. Even Taylor Poop and Taylor Swift, random comments. Okay, so 5 and 2, all we do is add them. Very good. Good job. Okay, let's see, Michaela. Good job, Emily. All right, Michaela, you ready? 1492.
Columbus sailed the ocean.
I was ready for someone to say it. I was waiting and waiting. Who's going to say it? Who's going to say it? Okay. So, What's the degree of the term? Put your hand down. It's Michaela's math problem.
So there's no variable, so 0.
There you go. It is 0. Because that's that one I showed you, the degree of the constant.
It's so sweet.
He is. Okay. So the degree of this term, which is just a constant, is 0. Very good. So 5. And tomorrow, before I give you your problems, we'll probably go back over this. Okay. So the directions say, classify each expression as a monomial. Taylor, do you have a question?
I want to answer.
Classify each expression as a monomial, binomial, trinomial, other polynomial. That's that one where there's 4 more terms. Or not a polynomial because of the rules. Then there's more to it. Then state the degree of each polynomial. So number 5, Taylor wants to do this one. So pay very close attention. 4x cubed y to the 5th power plus 2xy.
Wait, so it's binomial.
Okay, hold on. So why did you say it's a binomial?
Because there are 2 terms.
Because there's 2 terms. 1, 2.
So it's mono plus mono equals 5.
Stop it. You're confusing me. All right, binomial. And then it says what's the degree of the polynomial. So how do I solve that, Taylor?
You, for both of them, but for both the terms, you add together all of the exponents. And so you get 8 and 2. So 8's the degree.
Okay, see, his explanation was off the chart, right, Aiden? I saw Aiden turn and look at him like, what? So his explanation wasn't quite correct, but he got the answer correct. So the term, I was expecting him to say like 10 or something, but okay. So you get the degree of the term, which is what, Taylor? 8. The degree of this term is 2. And instead of adding them together, you choose the highest, and that is your answer.
I think you meant to have like 3 plus.
He did, but it didn't quite come out that way. That's why Aiden just flipped his head over at Taylor like, what?
I also finished the problem beforehand, so that might have something other to do with it.
Yeah, because you weren't thinking about what was coming out of your mouth. Okay, so 8 is the highest because 3 plus 5 is 8. And remember, 1 and 1 is 2. So 8 is the degree of the polynomial. Are there any questions about that? Okay. 7. You've already done 1. Put your hand down. Michael. Negative 4x squared y plus 5xy plus y minus 8. So Michael, after you've written this down, you tell me what kind of polynomial is it? It is an other poly. It's other because how many terms are there, Michael?
4.
That's right, there's 4. 1, 2, 3, 4. So it's other polynomial. Now, we have to find the degree of this whole polynomial. So how do we do that?
You just add the exponents to each other for each term.
For each term. What is the degree of that term? What is the degree of that term? the degree of this term? What's the degree of that term? 0. Which is the highest, Michael? So therefore, the answer is 3. Now, once you sit and look at that, and please ask questions if you're not sure where Michael got his answers here. Anyone? Anyone? How are we feeling right now?
Great.
Okay, well, we're going to pause. This is part 1.